Today we are going to see about data visualization. Introduction. Visualization is the easiest way to analyze and observe information. It is the first step for any kind of data analysis work. Visuals, or better called data visualization, help us to easily understand a complex problem and see certain patterns. Data visualization basically refers to the graphical or visual representation of information and data using visuals elements like chart, graph, map, etc. Python is an interpreted language with a strong core functions, basis, and powerful modular aspect which allows us to expand the language with external module that offers new functionalities. Thus, we have an extensible language with tools to accomplish a single task in the best possible way. Modules are often organized in packages. A package is a structured collection of modules that has same purpose. Data visualization in Python can be done via many packages. One example of a package is matplotlib. Matplotlib package can be used in Python scripts, Jupyter Notebook, and web application servers. In Python, we can use two exclusive libraries for visualization, commonly known as matplotlib and seaborn. However, we shall be restricting ourselves to usage of matplotlib only. We'll see about matplotlib. Matplotlib is a 2D plotting library, helps in visualizing figures. Matplotlib is used in Python as it is a robust, free, and easy library for data visualization. It is easy to learn and understand. Data visualization is an important part of business activities as organizations nowadays collect a huge amount of data. Sensors all over the world are collecting climate data, user data through clicks, car data for prediction of steering wheels, etc. All this data collected holds key insights for business, and visualization makes these insights easy to interpret. Data is only as good as it is presented. Matplotlib is the most popular plotting library for Python. It gives us control over every aspect of a figure. It supports interactive and non-interactive plotting and can save images in several output formats, PNG, PS, and other formats. Matplotlib is the whole Python package or library used to create 2D graphs and plots by using Python scripts. PyPlot is a module in Matplotlib which supports a very wide variety of graphs and plots, namely histogram, bar chart, power spectra, error chart, etc. It is used along with NumPy to provide an environment for MATLAB. It supports interactive and non-interactive plotting and can save images in several output formats like PNG, PS, and others. PyPlot provides the state machine interface in the plotting library in Matplotlib. It means the figures and the axes are implicitly and automatically created to achieve the desired plot. For example, calling plot function from pyplot is automatically create the necessary figure and axis to achieve the desired plot. Setting a little while when automatically see the title to the current object axis. The pyplot interface generally preferred non-interactive plotting, that is scripting. Each pyplot function makes some changes to figure like creating a figure, creating a plotting area in a figure, plotting some lines in a plotting area, decorating the plot with labels, etc. Next is NumPy. NumPy is another library which helps in process of plotting graphs, charts using pyplot in NumPy. NumPy stands for Numerical Python. NumPy is the core library for scientific computing in Python. It provides a high-performance multidimensional array object and tools for working with these arrays. Using NumPy, a developer can perform the following operations: mathematical and logical operations on array, Fourier transformation, and routines of shape manipulation, operations related to linear algebra. NumPy has inbuilt functions for linear algebra and random number generation. We can install NumPy using the popular Python package installer pip. Type the following command at the command prompt: c:/pip install NumPy. NumPy will get installed in our system and will be ready to be used. Installing matplotlib. Before we start plotting graphs in matplotlib, it needs to be installed first. For the installation of the matplotlib, follow the steps listed below. Open command prompt and run command prompt as an administrator. Type cd/ to move to the root directory. Step 3. Type pip install matplotlib. With internet connection, please ensure that the system has Python shell installed before installing matplot library. Installation of matplotlib will start. After the installation is successfully done on the system, an appropriate message after the successful installation of the above library package matplotlib, we can plot various types of graphs in Python shell using pyplot methods. Types of visualization. Matplotlib can be used to explore the basic plotting capabilities for single or multiple lines. We can add information to plot such as legends, axis, label, and titles. It also provides the capability to save a plot to a file. There are many types of visualization available with matplotlib. Some of the most famous are line plot, scatter plot, histogram, box plot, bar chart, and pie chart. Basic visualization rules. Before we look into some of the plots, let us introduce some basic rules. These rules help us to make nice and informative plots instead of confusing one. Before you plot or create any chart or a graph type, make sure to import the matplotlib.pyplot library by giving the command import matplotlib.pyplot or import matplotlib.pyplot as plt. Here plt is an alias name for pyplot, so now you can use plt for typing pyplot commands as plt.command. Along with pyplot, if you are using import numpy as np, the next step is choose appropriate plot type. If there are various options, we should compare them and choose the one that fits our model the best. Third, when we choose the type of plot, one of the most important thing is to label the axis. If you don't do this, the plot is not informative enough. When there are no axis label, we can try to look at the code to see what data is used, and if we are lucky, we will understand the plot. Fourth, we can add a title to make our plot more informative. Fifth, add labels for different categories when needed. Sixth, optionally we can add a text or an arrow at relevant data points. Seventh, in some case we can use some sizes and colors of the data to make plots more informative. For drawing simple charts, in the line charts and scattered charts are most similar. The only difference is the presence or absence of lines connecting the points. Also, using plot function of pyplot, you can create both of these basic charts. Basic nomenclature of a plot. Pyplot provides the state machine interface to the plotting library in matplotlib. It means that figures and axes are implicitly and automatically created to achieve the desired plot. For example, calling plot from pyplot will automatically create a necessary figure and axis to achieve the desired plot. Setting title will then automatically set the title to current axis object. The pyplot interface is generally preferred for non-interactive plotting, that is scripting. Matplot figure can be categorized into several parts as below. Figure, it is a whole figure which may contain one or more than one axis plots. You can think of a figure as a canvas which contain plots. Axis, it is what generally think of as a plot. A figure can contain many axes. It contains 2 or 3 in case of 3D. Axis objects, each axis has a title, an X label and a Y label. Axis, they are the number line like objects and take care of generating the graph limits. Artist, everything which one can see on the figure is an artist like text objects, line 2D objects, collection objects. Most artists are tied to axes. Labels, to manage the axis dimension of a plot. Another important piece of information to add to a plot is axis labels, since they usually specify what kind of data we are plotting. Title, just like in the book or a paper, graphs, the title of graph describe what it is. Matplotlib provides a simple function, plot title function, to add title to an image. Legend. Legends are usually explained what each line means in the current figure. Line, plot or chart. The line, plot or chart is a type of plot which displays information as a series of data points called markers connected by straight lines. In this type of plot, we need the measurement points to be ordered typically by their x-axis, values. This type of plot is often used to visualize a trend in data over intervals of time, a time series. The line chart represented by a series of data points connected by a straight line. Generally, line charts are used to display trends over time. A line chart or a line graph can be created using the plot function available in PyPlot library. We cannot only just plot a line but also explicitly define the grid, the x-axis and y-axis scale, and labels, titles and display options. To make a line plot with matplotlib, we call plt.plot function. The first argument is used for the data on the horizontal axis and the second is used for the data on the vertical axis. This function generates your plot but did not display it. To display the plot, we need to call plot.show function. Markers and line style. In the practical implementation example that we are going to implement in successive subtopics, all the plots are made of points with lines joining them. The points are the pairs x, y from the x and y input list. We pass to plot function. The lines are the straight segments connecting to any two adjacent points. Points are almost invisible if not for the edges in the graph. However, they are the real generators of the plot because points marks positions. As a result, they are called markers in matplotlib terminology. By default, matplotlib draws markers as a single dot and lines as a straight thin segments. There are situations where we would like to change either the marker style to clearly identify them in the plot or the line style. In order to draw a line plot, the steps to be followed are as under. Steps: importing matplotlib, plt.plot of x, y, color and others, plt x label, your text, plt y label, your text, plt set title, your title. Plt.show function displays a figure. So now let us do some practicals. First exercise is a simple program to draw a line chart. For this we have to import matplotlib.pyplot as plt. So now plt.plot 1, 2, 3 and 5, 7, 4 are the parameters given to this plot. is a two list 1 2 3 and 5 7 4, x-axis and y-axis. If you see this x-axis, it starts from 1 1.25 1.5 up to 3, and here in the y-axis it starts from 4 5 7. Then plot dot show, it matches 1-to-1 values, 1 with 5, 2 with 7 and 3 with 4. Now the question number 2 is program to draw two lines along with proper title and legend. Two lines along with proper title and legend. So how we are going to do? Import matplotlib.pyplot as plot. We have created 4 list, x equal to 1 2 3, y equal to 5 7 4, x2 equal to 1 2 3, y2 equal to 10 11 14. So we are going to plot using this list. As usual, plot plt.plot of x comma y. Here we are introducing label equal to first line, and similarly plt.plot x2 comma y2, label equal to second line. And in the question what they have asked, proper title and legend. So title is new graph and legend x label y label. plt.x label plot number, plt.y label important variable, plt.title new graph. So next what we are going to do is we are going to call the legend function, plt.legend. Then as usual plt.show. Let us see the output. It created two lines, first line and second line. In the left hand side, if you see, it has been marked as an important variable, title, new graph, and in the bottom plot number. If you see this, 1, it starts with 1, ends with 3. If you compare both the question and the answer, where they have plotted, first line has been plotted in the legend, second line has been plotted in the legend, and plot number is in the bottom. X label, y label important variable, plot.title as new graph, and plot.show, it shows the how the way it plotted. And if you notice x and y, so first value 1 comma 5, x equal to 1, y equal to 5 in the blue line. Similarly x equal to 2, y equal to 7, and third x equal to 3, y equal to 4. And if you see that x2 y2 is another line, x2 equal to 1, y2 equal to 10, x2 equal to 2, y2 equal to 11, and x2 equal to 3, y2 equal to 14. So this is how it plots multiple lines. Next we are going to see about the plotting line chart in a different view. So here we are introducing NumPy. Import NumPy as NP. import matplotlib.pyplot as plt. Here we have t equal to np.arrange. Arrange is a built-in function from NumPy. It arranges 0 to 2 incremented by 1. 0 to 20 increment by 1. And S is a list 1 to 20, S2 is another list 4 to 23. So T is common using the arrange function. Then we have to plot plt.subplot 2, 1, 1. plt.plot t, s. T is common to S and S2. So first we are going to plot t, s, and y label values, title, first chart, grid equal to true. What grid does? Grid will divide your image into grid. plt.subplot 2, 1, 2. plt.plot t, s2. plt x label items, plt y label values, plt title second chart, and grid equal to true. Finally plt.show. So output is like this. Values in the left hand side, items in the bottom, first chart, second chart. So as usual, it starts with the t value 0 and s value 1. So 0, 1 ends with t equal to 20, s equal to 20. And in the second, it starts with t equal to 0, s equal to s2 equal to 4, and t equal to 20, s2 equal to 23. Next question is plotting line chart in a different view. So as usual, import NumPy as np, import matplotlib, and t is equal to np.arrange 0 to 20, increment by 1, s2 s equal to 1 to 20, list s2 equal to 8 to 27, another list, and the same as previous question, just only one addition, plot subplot underscore adjust. So adjust the horizontal space and the width space, h space and w space 0.4, 0.4, and rest of the things, everything is same. Let us see the output. It created the two plots with the grid with the line item, and it starts from 0, 1 to 20, 20, and second chart starts from 0, 8 to 20, 27, and only difference is it has the spacing 0.4. Next we are going to call a function, Python function, to plot. So here the given is a list 1, and we are going to call f1 plot as a function with the argument of list 1. How to define the function? We have to use the def to define the function, and the function name is fn plot, the argument list 1, and using the plt.plot of list 1, plt.title marks line chart, plt x label value, plt y label frequency, plt.show. Here the new thing is how we are calling a Python function. The output is, it starts from 50 from the 0th element, and 50, 50, 50, 65, 65, 75, 75, 80, 80, and 90, 90, 90. So far we have seen the line and grid. So now we are going to see the scatter diagram, scatter plotting. So given is weight and height. Weight is a list with some random numbers, and height is with some random numbers, and we are going to use this weight and height in the scatter diagram. plt.scatter weight comma height, plt.title markers line, x label, y label, and it gives the scatter diagram like this, and we'll compare side by side. So weight and height, weight is 83.3, height is 167 for the first element, 74, 113.7, 64.5, 124.8, and so on. So if you see this x-axis and y-axis, it plots a dot, a scatter dot in particular location. 83.3, 167. So it is in between 80 to 85 and 60 to 70. Similarly, it plots all the dots. Next we are going to see about the bar plot, and here we are going to use the range function. Given y-axis is 20, 50, 30, x-axis we have to get the range. Okay, we'll see like how the range works. So if we print x-axis for the given parameter, it gives the range of 0 to 3, meaning 0 from 0 up to third element, 0, 1, 2. So this is the meaning for the range function, and it gives the output of a bar chart. Let's compare one by one. Y-axis 20, 50, 30. So it gives the y-axis up to 50, and x-axis 0 to up to 3, meaning 0, 1, 2, 3 elements. And plot dot bar x-axis, y-axis, width equal to 0.5, color orange, plot dot show. So it has mapped up to 20, up to 50, up to 30 in 3 diagrams, in 3 bar chart. The next is horizontal bar. So we are importing the matplotlib and numpy. Here objects, it's an array of objects. If you see the bracket, it's a round bracket, and list is a square bracket. So we have array of objects, and ypos equal to arrange length of objects. What is length of objects? Another function, count the length. Python 1, 2, 3, 4, 5, 6. So we have length of objects is 6, and performance 10,86421. And how to define horizontal bar, plt dot bar h. What are all the things we are going to define? Length of object is 6 and performance is a list, align equal to center, color equal to orange, and plt dot ytix y underscore pos comma objects. As usual, x label, title, and plot dot show. So it created horizontal bar. So let us compare with side by side. Objects has been listed in ytix, and x label usage in the x-axis, title programming language usage on the top, and performance 0 to 10, the range from 0 to 10, and objects starts from Python, C++, Java, Perl, Scala, Lisp up to 6. And Python has been mapped with 10 and C++ 8, Java equal to 6, Perl 4, Scala 2, and Lisp with 1. Next is histogram with some random number. So to generate random number, we have to import numpy as np and y equal to np.random.rand. That creates the random number of 1000. Let us see how it creates the random number. So if you just print y equal to np.random.rand of 100, this is the way it prints the random number. And we'll go back to our program. So if you see the random number, it prints 1000 random number and plt.histogram of y of the random number, plt.show. So it prints the histogram. Next is histogram with data students as a list 1, 11, 21, 31, 41, 51, and we are going to plot histogram with data students, bins. Bins equal to 0, 10, 20, 30, 40, 50, 60, and weight equal to 0 to 33, 10, 1, 0, 33, 6, 8. Face color equal to y, edge equal to red. So here, if you notice, the bin, it starts with 0 and first weight is 10, and second bin starts from 10 and weight is 1, and third 20 to 30 is 0, 30 to 40 is 33, 40 to 50 is 6, and 50 to 60 is 8. And here we are doing one more thing, that save file students.png. So it saves this image as a PNG format in your computer.